Hello, it is April 3rd, and we will be preparing for our quadrilateral properties test by practicing. The test will be due on Sunday night. It's Friday morning, so you have plenty of time to practice to complete the exam. So on this first page here, we have all of our different types of quadrilaterals that we need to know about. We have our parallelogram, our rectangle, our rhombus, our square, our isosceles trapezoid. We're going to be referring back to these as we go through. You need to know all your properties. I don't know how else to say it. You must know all of this. You have to have it memorized. In school, I will give you quiz after quiz, just memorizing this. You need to know all your properties and how it works. These are all the properties of the parallelogram. A rectangle has these properties and these properties. A rhombus has these properties and these properties, and a square has all of them. You need to know that. You need to know how they're related to each other to prove a parallelogram. You prove one of these five. To prove a rectangle, you prove it's a parallelogram first, and then one of these two. To prove it's a rhombus, you prove it's a parallelogram first, and then you prove one of these. And to prove a square, the square is the baby of the rectangle and the rhombus. So first you prove it's a parallelogram, then you prove it has a property of daddy rectangle, then you prove it has a property of mama rhombus. The other thing you have to have memorized is for coordinate geometry or how do you proves, you need to have all this memorized, period. If you have all this memorized and can do distance formula, then coordinate geometry proofs should be easy. So let's start with our properties. Which quadrilateral has diagonals that always bisect its angles and also bisect each other? So we look here. Which one has diagonals that bisect the angles? Let's just clear the ink from all this. Which one has diagonals that bisect the angles? The rhombus does. The square does as well, so the answer has to be square or rhombus. So your answer would be choice 1. It's just knowing your properties. If you know your properties, these are easy questions. They're also very common regions questions, and things build on it. Given 3 distinct quadrilaterals, a square, a rectangle, and a rhombus, which must have perpendicular diagonals? Well, let's find perpendicular diagonals. We have perpendicular diagonals here, so a rhombus. Remember, a square has all these, so a rhombus and a square. That's it. If you look at the rectangle, these are not perpendicular. These are not right angles in here. These are obtuse, these are acute, so it's the rectangle, it's the rhombus and the square. So it's just a matter of knowing your properties and going from there. Now this question, you need to understand what it's asking. A parallelogram must be a rhombus when? So basically it's saying, how do I prove a parallelogram is a rhombus? The answer is one of these three. To prove a parallelogram is a rhombus, it has to be one of these three by definition. So perpendicular diagonals, diagonals bisect the angles, or consecutive sides congruent. So which of those is a potential answer? Diagonals are perpendicular. Again, it all comes back to just knowing your properties. You need to know everything on this page. A parallelogram is a rectangle. Well, for a parallelogram to be a rectangle, we need to prove one of these. Again, you have to understand that that's the answer. It's easy. If you want to prove that the parallelogram's a rectangle, you have to prove one of these, either a right angle or congruent diagonals. And which one is there? Consecutive sides perpendicular. Remember, perpendicular lines form right angles. We're going to move on to number 6. It's telling you that it's a rhombus. It's saying that PR equals 16. It wants the perimeter of this thing. So to find the perimeter, I need to find a side. Once I find a side, since a rhombus has all sides the same, I could find the perimeter. Now, what shape do I have within the shape here? Since the diagonals are perpendicular to each other, I have a right triangle. I also know that diagonals bisect each other. So if PR is 16, then this must be 8 and 8. If QS is 30, then this must be 15 and 15. Because diagonals bisect each other, they cut each other in half. So what do I have? Let's kind of like redraw it here. I have a right triangle. I have 15. I have 8. I want to find that. To find the third side, when I have two sides in a right triangle, that's when I use Pythagorean theorem. So it's 8 squared plus 15 squared equals x squared. 64 plus 225 equals x squared. 289 equals x squared. Square root. X is 17. If that's 17, a rhombus has all sides the same. So the perimeter is 17 times 4, which is 68. It's a little ugly. Let me rewrite that. 68. Boom. So whenever you give you a rhombus, understand that a rhombus has right triangles within it, diagonals, because diagonals are perpendicular. Diagonals also bisect each other, and from there you do your Pythagorean theorem. So you'll see one of those in your exam. 7's the same thing. I'm not going to go over that now. Number 8, another very, very common Regents question. This goes back to what we did in the first unit, except now we're adding in the parallelogram properties. So, did it give us any important information in the question? It said that it's a parallelogram. If it's a parallelogram has opposite angles congruent. Any other important information? No. So we look for, going back to Unit 1, linear pairs, angles of a triangle. I see a triangle right there. So 70 plus 65 plus x equals 180. 135 plus x equals 180. X is 45. Linear pair. 180 minus 45 is 135. It's asking for angle KSO. That's angle KSO. That's your answer. Look for linear pairs, look for angles of a triangle, see if they give you any important information. In this case, a parallelogram. A parallelogram has opposite angles congruent. You can also have alternate interior angles with that as well. I usually don't do two of the same, but I'm going to do two of the same here. Although something's missing. Yep, there it is. Just because this is such an important type of question, so, and it doesn't take too long to go over, so why not? Is there any, so let's put the information into the picture. Let's go blue. So CE is congruent to BE, very important. CE, BD, mark the sides, mark the angles. Again, it's going back to Unit 1, but if you don't do that, you're not going to get very far. Angle D is 112. So it says it's a parallelogram. A parallelogram has opposite angles congruent. Linear pair. 180 minus 112 is 68. Well, if this is 68, I already marked that those are the same. Now I see this triangle. 68 plus 68 plus x equals 180. 136 plus x equals 180. I do the algebra. I get 44. Again, we've been doing this since the beginning of the year. There's a lot of little components to this. Use the notes. All right, the notes are in the front of the packet for quadrilateral properties with all of this. It's pretty straightforward as long as you know what to look for. All right. Wow, this is a pretty quick review sheet. Prove that triangle ABC is an isosceles right triangle. Oops. Well, triangle ABC is an isosceles right triangle because, well, I go back to my how do you proves, which you have to have memorized. Here they are. Isosceles has two congruent sides. Right triangle, show the sides fit into Pythagorean theorem. Because it's a little smaller. Because for the isosceles, it has two congruent sides, and for the right triangle, and its sides fit into Pythagorean theorem. So that's one. Now let's get this thing graphed and do the work from there. A is 1, 1. Oh no. How about I do this in purple? Let's see if it works. Yay, purple. A is 1, 1. B is 2, 5. C is 6, 4. So I said that it has two congruent sides. I'm going to find the distance of AB. I'm going to find the distance of BC. I'm going to find the distance of the third side as well. In order to show that it fits into Pythagorean theorem, I have to find all three sides. So my distance formula, I really hope you know your distance formula at this point. Delta x squared plus delta y squared. AB is 1, 1, 2, 3, 4. 1 squared plus 4 squared. 1 plus 16. Rad 17. BC 1, 2, 3, 4, 1. 4 squared plus 1 squared. 16 plus 1 is rad 17. AC 1, 2, 3, 4, 5. 1, 2, 3. 5 squared plus 3 squared. 25 plus 9. Rad 34. Now I put it all together. I said that it has two congruent sides, so tell me what the two congruent sides are. AB is congruent to BC because they have the same distance. Then I said that its sides fit into Pythagorean theorem, so I'm going to show that. A squared plus B squared equals C squared. A and B are the legs. Rad 17 squared plus rad 17 squared equals rad 34 squared. Squares and the radicals cancel. 17 plus 17 equals 34. It fits. That's it. I'm not going to go through the rest of these proofs. Again, you have them written out on the key, which I sent to you, and it's also on Schlansky.com. You know, you have the how do you proofs. It's a matter of you practicing. And again, it's all right here for you. All right, you need to know this. You need to have this memorized. You just no other way around it. If you do, it's a very, very easy 4 or 6 point readings question. There's one more type of question that I want to go over, and that's it. It's a relatively short exam, but I understand that the questions themselves are kind of long. It wants me to prove that triangle AED, I think it's a little bit bigger. There's a video of me going over this exact question already, so I'm really not going to go through it. I'm not going to write the whole thing out. It wants me to prove that triangle AED is congruent to CEB. It's telling me that it's a parallelogram. So what properties of the parallelogram are going to help me? Well, a parallelogram has all of these properties. So which of these properties are going to help me with my triangles? Let's take a look. Opposite sides are congruent. So I can say AD is congruent to BC. A parallelogram has two pairs of opposite sides congruent. A parallelogram has, you're not going to see it in the picture, but this is based on the fact that they're parallel, congruent alternate interior angles, congruent alternate interior angles. Diagonals that bisect each other. And finally, this has nothing to do with the parallelogram, but we do have vertical angles. So I only need 3 things. I got all 6. They're there. Again, I'm not going to write out the actual proof again. You have it in the key. You also have this exact video, this exact problem in the triangle proofs given parallelograms lesson 1. It's just utilizing the properties of the parallelograms to help you with your proofs. So I'll mark up this next one as well, but I'm not going to write it out. It wants me to prove DM is congruent to BM. Well, I'm always proving triangles are congruent. It's pretty obvious that I'm proving these. So it's giving me that ABCD is a rectangle. What property of the rectangle is going to help me with my triangles? Well, there's 2 in this particular example. A rectangle has opposite sides congruent because that's one of the parallelogram properties. A rectangle also has congruent right angles. M is the midpoint of AC. A midpoint creates 2 congruent segments. I have side, angle, side. I can then state what they want me to prove. CP, CP, CP. Again, refer to the key. I'm not going to write the whole thing out. So that's it. Practice. It all comes down to knowing your properties. And for coordinate geometry, these are of course based on the properties that are here, but no, you have options, but I like to make it simple. We're always calculating distance. I'll just write that down for you. For coordinate geometry proofs, you're always calculating distance, except for trapezoid, in which case you're calculating slope. So, worst case scenario, you don't have to do, find distance. If you find all the distances, you'll at least get some points. So again, practice, ask me questions, use this video, use the key, use everything that you have, and practice. That's all I got. Practice, 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 ask questions, and enjoy your weekend.